we're solving problem 10 from the 2020 AMC 12B. In unit square ABCD, the inscribed circle omega intersects CD at M, and AM intersects omega at a point P different from M. What is AP? So this is point B here that lies on AM, and we have this. First thing to note is that this square is a square and it's a unit square. So if it says the inscribed circle omega intersects length CD at point M. We know this has to be true, that these lengths are equal because an inscribed circle, well, it's got to be tangent to 4 points, and those are the midpoints of the square. So therefore, these lengths are 1/2, because we know that since it's a unit square, each side length is 1, and you want the side lengths to sum to 1. So the first thing we can do is, well, let's just create imaginary line N to P, such that it creates this right triangle APN. Now notice, APN is similar to triangle AMN, so let's just write that. APN, just similar to AMN, because they share a similar angle and side length ratios. Now, we can also find out the length of segment AM. Since we know that each corner of a square has to be 90 degrees, we can use the Pythagorean theorem using our height is 1/2 and length is 1. AM is equal to 1 squared, which is 1, plus 1/2 squared, which is 1/4, and square root that, which gives us square root 5 over the square root of 4, which is 2. So this is our length for AM. And, well, this is important. These two triangles are similar. It's important because we can then set up ratios of the sort to solve for AP. So we use the two known side lengths for the small triangle AP and AN, where AN is also 1/2, likewise to MD. And this ratio is equal to AN over AM. Since we know that this is 1/2, this is 1/2, and we just solve this to be root 5 over 2. We get that AP is equal to 1/4 divided by square root 5 over 2. So then the 2 multiplies here. AP is equal to 1 over 2 root 5. But this answer doesn't show up on any of the answer choices because when you look on the test, all the answers, all the denominators are rationalized. So we therefore have to rationalize the denominator by multiplying both sides, top and bottom, by 2 root 5 to get 2 root 5 over 20, or AP in its most simple form is root 5 over 10, and that is our answer for this problem.